All right, everybody. So I just wanted to take a little bit of time here to go through the lab practical number one to kind of show you. I won't do the whole thing, but I'll show you kind of basically how so some of the quickest ways to do it. So number one, so I need to download the petroleum data. So here I'm going to download the wells, and I'm going to download the fields. And something that I needed you folks to notice is that there's metadata associated with these, right? So you can actually know what all of the column headers mean, right? If you scroll down. So, there's a lot of column headers here. And so yeah, that's one way to know what you're looking at when you're exploring the data. So that'll be important later when we need to filter. So, okay, so I've downloaded my data, and now what do I need to do? So there's going to be a bunch of points here. So I need to filter them to reduce and figure out what my, question might be, and tell a story. So, okay, so I know that I can do this in QGIS. I can do this in Carto. I think I'll go ahead and do this in Carto. So, because actually people had the most trouble in Carto, so I'm going to go ahead and do that. So I've already, you folks know how to upload the data, so I've already done that. So and this is a problem people ran into. So I'm going to recreate this. So petroleum fields, petroleum wells. So petroleum fields, petroleum wells. Then these files also came in, petroleum fields _1, petroleum wells _1. So I'm going to say create map. So this will take a minute or so to bring the data in. So we can see now that the data are in. And so you folks were getting really hung up here with petroleum wells that it was saying you needed a geocode. And so I said, right, make sure that you look at the data. So when we go in and look at these data, I can see that these are just notes, right? This is nothing that we need to map. So this one, I don't even need this layer, because this one, for instance, let's go back to the wells data. This one's, for instance, again, if we look at the data, again, that's why it's really important to look at the attribute data. Okay, so I've got my Latin longe, this is telling me all the different well types, the county they're in. So really important to look at the data. So, and I also know that I don't need to geocode this one. So again, so make sure you look at your data and know what you have and when. Okay, so I know my wells are what I need to filter. So if you folks remember how to do this, add an analysis, filter by column value. Okay. And let's see here. So I want to, I'm in my wells. So which column do I want to filter by? Symbol. Okay. And, okay, there's all these different things listed for symbol. Well, what did those mean? So we can go back to our metadata. Let's see here. I want to, for whatever reason, let's look at the temporarily abandoned wells. Well, I want to. So okay, I want to. Let's see. These are temporary. So I want to look at temporarily abandoned gas wells and temporarily abandoned oil wells. So that means they might come back to them. So TA gas. So I'm going to need to make a layer TA gas. So let's go in here. TA gas. All right. Apply that layer. Okay, so there's my TA gas. Okay, so I'm going to pop that out. Then come back and do another analysis here. Filter by column value. Let's see here. And what was the other one we wanted? Is it TA oil? Temporarily abandoned oil, TA oil. Okay. So we'll go in here. Analysis, add analysis. Okay. We're going to go to symbol, TA oil. Okay. So we're going to do that. Okay. So that is done. So again, we'll go back. We'll pull out this one. So we can style them separately. This is going to be TA oil. This is going to be TA gas, just to keep them straight. Okay. And, you know, I went ahead and pulled these out so that I could see all of the wells if I wanted to. So if I go to TA gas, let's see here. Let's just change the color to blue. Okay. And then TA oil, let's change the color to green. Okay. And then I'm going to have to, oops. So fields, I want those all the way at the bottom, right? Because I want the points to be on top. And if I hide this layer, so there are my, so there's my, and let's see here, I want to, okay, I want to add a legend. Yeah, layer selector is always good too. Okay. Okay, so there's my TA oil, which is green. There's my TA gas, which is blue. Okay. So now I've got, and I could have, yeah. Anyway, I'll just leave it at that. This is kind of the simplest. Oops, sorry. Okay, this is kind of the simplest way to talk about this. So, lab practical 1, question 1. Okay, so we've got our, we've got our two different wells. Oh, sorry, we've got our two different, we've filtered our well types. And we've also got our fields, right? So from this point on, you could ask a whole bunch of different questions. You could do a whole bunch of different analyses. So I'm not going to do anything like that because, who knows what you might have chosen. So, but anyway, so that is basically an introduction to that. So pretty easy once you know what you're doing. Okay, so now I can move on to question number 2. So please take this address list. Okay, and it's asking for is to make a set of points. So you can see the data here, that it's basically a street address, city, state, zip, and some kind of ID that we don't really know what that means. And so we know that this is going to have to get geocoded somehow. So the best way to do this is actually to put it right into my maps, because we know that Google Earth is the best geocoder. It's better than Carto or QGIS at geocoding, but the problem with my maps is you can't get the geocoded layer back out. So if we needed to use this for something else, then we wouldn't want to use my maps for geocoding. We'd want to use Google Earth. But since all we need to do is generate a map, it's not asking for us to then do anything else with these data, we can just use my maps. So downloading the data, going to my maps. So I'm just going to create a new map, and this is exercise or lab pract 1, question 2. Okay, so all we got to do is import the data. So let's see here. Here's my downloads. Okay, there's the address list. It's a CSV, so we know that Google will accept it. So, and then the address, the city, the state, the zip. This is what it'll use to do the geocoding. And then I'll just title them by family ID because that's the only thing left. I could have titled them by zip code or whatever you might think is important. So right now it's spending time loading. So it is doing the geocoding as we speak in the background. So 34 rows couldn't be shown on the map. So let's see what is going on in the data table. So if I wanted to, right, I could try to fix these, right? So apartment J, for instance, that's not going to be very useful for geocoding. So there you go. So if I took out apartment J, yeah, these apartment numbers really do, like, you need that for a mailing address, but you don't want that when you're geocoding. Here it looks like they forgot a space. A bunch more apartment numbers. Roxbury looks like they needed a drive or road or something like that. So anyway, and it was not part of the exam. You didn't have to actually correct any of these, but just to show you that there is a way to correct these. And so say don't worry about it. So anyway, here's your map, and you can color it by zip code, if you wanted to. So style by data column. If I did want to look at zip code, I could do that. So anyway, this was a pretty easy, quick little question. So hopefully that was only going to take you a couple minutes. And then if I go back to the lab practical, now we're talking about the DEM. So question number 1, you could have used QGIS or you could have used Carto. I used Carto. You could have easily used QGIS for that. Here, question number 3, you need to use QGIS because it's the only program we have that can deal with raster data. So I'm just downloading those data to DEM, and I'm going to go to my QGIS, layer, add raster layer, and I'm going to look at my downloads. There it is. Okay, so I'm adding my DEM. And it looks like it's in lat longe. So you can see in the coordinates here that's giving me lat longe for that. So okay, let's see here. So the question is asking, okay, and there you go. And while I was working in QGIS, this went ahead and colored by zip code. So there you go, colored by zip code. Pretty nice. Okay, so the question was asking, okay, colored map demonstrating elevation, colored map demonstrating steepness, and a map demonstrating some kind of band map, or band math, sorry. Okay. So elevation, we know we have elevation here already, right? This is a DEM. And so we can go in and style this. So let's see here. Single band pseudo color. Yeah, I'll just go with the default there, classify. So here's all the different classes for the elevations you've got. Apply. So okay, so it was that easy, right? So that is the basic thing that you need to do in order to color by elevation. Now, I would actually go a step further and put a hillshade underneath that. It just makes a better elevation map. So if we go to raster, then we go to analysis, hillshade. So I've got my raster data. I won't do any vertical exaggeration right now. Azimuth of the light, this is just the direction that the sunlight is coming in at. 315, so that's going to be coming in from the west. Altitude of light, again, you can change these if you want your shading to look different. I'm just going to leave them as they are. So I'm going to run that. Okay. And we want to increase the transparency here. And I'm not exactly happy with my hillshade there, but looks okay. Okay, and if I go back into my hillshade, raster, analysis, hillshade. Again, I want to make sure I select the proper file, which is my DEM. Azimuth of light, altitude of light. We could, now if you wanted to, you could do some vertical exaggeration. So if I don't even know, let's try 10. Let me, okay, let's see if that really did anything. They look exactly the same. So again, raster, analysis, hillshade. Let's say a z factor of 100. Oh, that actually increases the noise here. So, okay, raster. Let's take these out for a second just to clean house. Okay, so let's see here, raster, analysis, hillshade. I'll go the other way, 0.5. Okay, run. So I'm just kind of playing around with the variables there. Yeah, I'm not really seeing much of a difference. So, but anyway, if you zoom close in, right, you see the hill shade. And the interesting thing about this file is actually close to where I grew up, is that it's there's not actually that much topography, right? So you're gonna see, you're gonna see some topography, and you see it. The more I exaggerate the topography, you see these little ripples, right, in the flat ground, which don't really, don't really lead to much. So that's why. So that's why the image looks a little bit noisy. Is that you've got a bunch of tiny little ripples, right? So I wonder if I were to go and run a hillshade again, raster analysis hillshade. Let's put the sun higher up. Let's put it at 70. And let's see what that looks like. So again, I'm just kind of messing with variables to get an image that I'm happy with. And I'm not gonna, so I won't continue to I won't continue to keep running this to make this video longer. But anyway, you folks get the idea. So analysis, hillshade. It's fine to just stick with the defaults. I wonder if I use Zevenbergen-Thorne formula. What does that do? Combined shading. What does that do? Multi-directional shading. Let's see what all that does. Oh, did I not have the right raster in there? Raster, analysis, hillshade. I probably had the hillshade in there. Okay, so multi-directional shading. Let's try that. I'm using the Zegberg run. So anyway, that's another way to do it. So put your hillshade underneath, and you've got your DEM. If I had a preference, I would probably decrease a little bit. It makes it look a little cleaner. Okay, so anyway, that's basically the first map. So the second map is steepness. So how do we do steepness? That's basically looking at slope. Okay. So if we go into raster analysis slope, so and I'll explain more about slope in another video, but it's going to work out better for you here. It's just so far, if you just say slope expressed as percent, and I'll explain why in a different video. So we ran that. Okay, so here's our slope, right? So if you were to just generate an image like that, that's fine. I could add some color. Okay, so the higher slopes. So it looks like we've got low to medium slopes, so we're only getting up to this magenta part, so you're not seeing any of this bright. You're seeing a few areas of bright. So, and the interesting thing about slope right now is if you look at these buckets, right, these are gigantic values. And so you could, if I wanted to know, where's my slope above 3 million. So where's my slope above 3 million? I could do some band math on that. So, okay, here's the slope. So if that's a slope, that's the map that you produce, that's fine. You can also, if you wanted to, looks like we need to reduce. Well, I should use a different color map here. Oops. So maybe we want to use, let's just say blues. Okay, and we'll increase transparency to try to bring those slopes out. Okay, and again, I'm just kind of messing around until I get a product I like. So this wasn't required at all, but if you want to lay elevation over slope, then you can do that. You could even put hill shade in there. So anyway, and now, so that's that second map. So the third map is doing band math, and that is just anything, right? So you go to the raster calculator. You could say, where's the slope greater than 3 million? Okay. Okay, so all those see a zero. Zero data is zero. One data is sorry. Zero data is black. One data is white. So that's showing you all the locations where you have really high slope. And again, 3 million. The number doesn't make sense to you right now, but again, we'll cover that. So I want to say 0 means no data. So that gets rid of all of those zeros. Okay, so if you look at so now, all of these points, right? Sorry, now we've gone to all the black is the high slope areas. So now if we go in here, let's single band pseudo color. Let's go back to the single gray. Okay. There you go. So I can turn them white. Okay. So and you can mess around changing the color, but yeah, you can mess around changing the color. I won't waste your time here on that. So anyway, now I'm seeing the areas of highest slope. So if you zoom in, those are the areas that are going to be real steep. But if you didn't even want to mess with slope because you're like, I don't even know what that 3 million number is, then you could go into raster. Okay, sorry, raster calculator. Now you could get the DEM, and where's the elevation greater than? Oh, sorry, I need to see what my elevation range is here. Okay, so it looks like it goes up to 275. So where's my elevation data? I want the high points. Where is it higher than 270? Let's see what we can get from that. So raster. So where are my elevations greater than 270? We're just gonna save that layer. Okay. All right. So that gives us those should be our highest elevations. So it doesn't look like that's what we got. Let me try that again. Maybe I think maybe I had the wrong data in there. That happens sometimes. Okay, so that's the importance of actually checking your data after you've generated it. So raster calculator. We'll do elevation 2. Okay, yeah, so anywhere the elevation is greater than 270. Okay. Was that not actually? Looks like very few places. So that's not a very helpful map. Okay, so let's go back. Raster analysis. Sorry, raster calculator. Let's see wherever it's greater than 260. Okay. Okay, well that gets us a little better, right? So again, we can do the same thing here, where, okay, we can, okay, an additional value 0 means no data. Okay, so it removed all the zeros, and now we can bring back the DEM a bit, or all the way. Okay, so now that gives us all the elevations above 260, so there's a couple high points over here. So anyway, band math doesn't have to be spectacular at this point. So I hope that was helpful for you folks, and I hope that that made sense. So see you later.